All right, 5C. The first question is number 1 that was asked. What is a frequency table? It's a table that shows how the different outcomes and how frequent they show up. There's one of them, two of them, three of them, or four of them. So that's what a frequency table. And explain what is meant by the categories and the frequencies. The categories are the different things that could happen, like people choose Diet Coke versus Diet Pepsi versus Diet Root Beer, and how often those choices are made, for example. What do we mean by the relative frequency? That means what percent is this of all the voters, all the choosers, all the people that are selected. And cumulative means you're going to say, okay, we'll take all the Diet Coke plus all the Diet Pepsi for the second one, all the Diet Coke, Pepsi, and root beer for the third one. You're adding up as you go down the list. Okay, so that's what number 1 was. Next question was 5. 5 is describe the importance of labeling a graph and briefly discuss the kinds of labels that should be included on graph. Well, on a graph, you want to know what this graph is about, the title. You need to have units marked. Units marked usually need to be equally spaced. And you need to say, what are the units for both sides? Then what's the units for what's the title of each axis? And then you need to know the spacing, so they need to know what those units are. If those are all on there, then you can read the data properly. So, what are the numbers? What are the units for those numbers? And what is the label for that axis? What is it what's measuring? Time, year, quantity, so on. Okay, that's 5. Next one was 12. 12, decide whether it makes sense. 12, your pie chart must be wrong because when I added the percentages in your wedges, they totaled 124. A pie chart is assuming that all the percentages include everything, which should be 100%, and so it does make sense that it's incorrect to have a total percentage of 124%. So this statement makes sense. Your pie chart must be wrong because it added up to 124. Couldn't happen if the pie chart's made correctly. 13. I was unable to make a bar graph because the data categories were qualitative rather than quantitative. Now the categories might be how many, maybe you were doing a survey of the woodland and the animal population, so you might have fox and deer and elk and bear and whatever, and those categories are qualitative. They're types of things, and then the measures might be a count of numbers, so that could work. But if it was how cute are the animals, then you're going to have trouble doing a bar graph for them. You could say the fox are so cute, but the measure on that's going to be tougher. So I was unable to make a bar graph because the data categories were qualitative rather than quantitative. So bar grapher does require you to have numbers, and if they're both qualitative, like the types of animals and the degree of cuteness, maybe that might be tough to get a numerical number. Otherwise, if only one of them is qualitative and the other is got a measure of those qualities, then we could make a bar graph. So it could go either way on that one. 13. 14. 14 says, I arranged the bars in my histogram so the tallest bar would come first. While histogram, the bars are from like 0 to 5, 5 to 10, 10 to 15. They go in order, so you cannot rearrange them so the tallest bar comes first, because there is already an order implied in a histogram, so this does not make sense. Okay? Alright, next one is 20. 20 says, qualitative versus quantitative. Determine the following variables as qualitative and quantitative. The amount of rainfall each month in a year in Chattanooga and Tennessee. So the amount of rainfall would be a quantitative. Next one, 22. The breeds of 120 purebred dogs. So they're not a number, they're just different breeds, like boxer, lab, retriever, etc. So that would be qualitative. Okay, and 26. Now we're into a new one. A bin frequency table. Choose 10-point bins for this data and make a frequency table. So then we're doing, and it says to do from 90 to 99, 80 to 89, etc. See, the low ones are 60. So I'm going to have some gap, and then I'll have 60 to 69. And then 70 to 79, and then 80 to 89, and 90 to 99. So if I bin like that, let's see, how many are in the 60s? There's 67, 64, 69, that's 3, 68, 4 of them. So 1, 2, 3, 4, 5. 6, 7, 8. So there's 4 60s. And then 70s, we have 78, 75, 70, that's 3, 77, 4, 79, 5. The 80s, 89, 83, 84, that's 3, 88, 4, 86, 5. The 90s, we have 95, 98, 90, 92. Let's see, what was that? 95, 98, 90, and 92. That's 4, 96. 5 of them. I must have missed some, because there should be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and I've got 5, 10, 15, 19. I missed one number in there, so let's see. This is roughly the idea. I'm missing one number, so I'd have to go back through and see. I had 4 60s, let's see. 1, 2, 3, 4. There's 5 60s. So there's 5 of each of the bins. Okay, so that's 26. 30. Next one. 30. Oh, and I forgot to label here what these were on this thing. And they didn't tell us what they were, so I can't label everything because they didn't give me the information. Just give me some data. Pie chart. The 5 leading tourist destinations in millions of visitors there are France, and they give you all these numbers, and then you're supposed to compute the percentages in each of the categories. So we need to do that first. So France, US, China, Spain, and Italy. And they have in them $76.8 plus 59.7 plus 55.7 plus 52.7 plus 43.6. That's 288.5 million. So the percentages, I'm going to have to take each one of these divided by 228.5. So I'm going to store that into X. All that means is I got that in X. So if I take 76.8 divided by X, that number, just saves a few keystrokes. That's 26.6%. And then the 59.7, I'll put this over here. 59.7 divided by X is 20.69, 20.7. 55 divided by X is 19.3. And by the way, I should be figuring out the number of degrees that is. So I would take this answer times 360 to know how many degrees the pie chart would be, and that's 69 degrees. The previous one, the 19, that was that one. This is the first one, France times 360, and that's 95.8 degrees, 96 degrees. The 20.7.207 times 360 is 74 degrees. 74.5, 75 degrees probably be better. Spain was 52.7 divided by X to get the percentage, 18.3. And then take that times 360 and I get 65.8, 66 degrees. And finally Italy, 43.6 divided by the total is 15%, 15.1%. times 360 and we get 54.4 degrees. Now this may be one off or so from there because of rounding, but it should be close to 100%, or 360 degrees. This should be close to 100%. This should be close to 360 degrees. And that's how you do that. And so then you'd make your pie chart. You'd set your protractor out there, make your circle, and measure from starting at 0, measure 96 degrees for one of them, then 75, which doesn't get you all the way around. Then a 69, it's about that much, and then about 66, and then a 54. Each one of those would be percent, and this would be France, US, China, Spain, and Italy, if you went in that order around it. Okay? That's 30. 31. Draw a histogram to display the bin data for age and Oscar winner. And so we have some gap here. We have 20 to 29, 30 to 39, 40 to 49, and 50 to 59, and 60 to 69, and 70 to 79. So in the 20s there was 1. We get up to 27, so I'm going to go 5, 10, 15, 20, 25. This one is only 1. Then the 30s are 27. The 40s are 30. Oh, it goes to 35, so I didn't make my scale big enough. 25, 30, 35, about there. And then 50 to 60 was 15. And 6 and 1. Okay? So the highest frequencies, 30 to 60s, is when you're most likely to win your Oscar. So go for it. Alright, 33. Now in 33 we're supposed to cell phone subscriptions. The following table shows the number of cell phone subscriptions in millions in the United States. You construct a time series graph for the data. Does the graph show a straight line growth, linear growth, or faster than that? So time series means we're going to lay out the time and even units. So we have 94, 96, 98, 2 every 2 years, so we're missing some years. I'll make this 94, 96, 98, 2000, 02, 04, 06, 08, 10, and 12. So this is the year, and then we have to get up to 325 million. So if I go 100 million, 200 million, 300 million, the first one I have to do is 24 million, which is down here. And then 44 and 69, and then it's 109, and 02 it's 141, 04 is 182. Getting a little bit offline here, but that's all right. 06 is 233. 263 and 08. 303 and 2010. 2012, 325. So that's a fairly straight line. So I'd have to say this looks like it's a linear growth. This is just roughly from, you can see how quickly I did this, and so it's looking fairly linear. There's a slight curve up, but not much. Okay? Two more. 37. 37. The following data shows the number of bachelor degrees in thousands conferred on men and women in the U.S. colleges and universities selected years. And what are we supposed to do on this? Consider the data sets. State whether the variables are qualitative or quantitative. Okay, so in 37 we have years, which are numbers, and we have numbers of men and women that get the degrees. So number of men, number of women, and so those are all quantitative, all numbers. And then we're supposed to say, draw a bar graph or a pie chart if the data is qualitative, and draw a histogram or a line chart if the data is quantitative. So we can do a histogram. We can do the years, 60, 70, 80, 90. Actually, I'll do a bar graph here. 2000, 10, and 20. And I'll do double bar, so we're going to have, this is the year, and this is number of degrees, in thousands, and we've got to get up to 1,000, so 200, 4, 6, 8, 1,000. And so in 1960 there was 260,000 for men, and for women was 140. So that'd be somewhere around here. In 70, 460 for the men. 1, 2, 3, 4, 2, 460 for the men. So that's striped this way. Women, I have it striped the other way, 335, which is somewhere around there. And then 80, 480. 500's there, so 480 is just below it. 480 and 475 almost equal. And then 90 is 490 for the men, and 530 for the women. And 2000's 510. 510, not quite as high as the 530. And 710 for the women. And etc. You can see how that's going, and that's kind of the idea what they want you to do there. Write a paragraph discussing the interesting features of the data revealed in there. The interesting feature here looks like that both of them are increasing, although the male is not increasing by as much. as the women, and so therefore the women pass the men in the number of women getting the degrees. Okay? And finally, 44. 44 says the figure shows the number of motor vehicle fatalities in the U.S. which alcohol was involved in since 1982. And approximately how many alcohol-related fatalities were in 1982? So if I'm just reading the graph, 82, that looks like the bar is about 27,000. And that's in 82. And then 2011, it's approximately 10,000. Okay, so that's A. B, what is the percentage change in alcohol-related fatalities over this period? Well, it went from 27 to 10, so that's down 17,000 compared to the starting amount. You always do it to the starting amount, 27,000, which is a percentage change of 63%. Down 63%. C. Total number of automobile fatalities in 1982, and the total number of fatalities was 43,945 in 82, and were 32,367 in 11. What percentage of all the fatalities in these 2 years were involved in alcohol? So 27,000 divided by 43,945, there was 61%, and then it went to 10 out of 32, 32.367, about 31%. So the alcohol related deaths dropped, the percentage of accidents that are related to alcohol dropped by almost half over that time period. Can you explain, can you offer explanation for the trend in this data? Yes, there's been a much higher focus on alcohol related deaths, and don't drink and drive, and you know, a friend won't let a friend drive drunk, and all those kind of programs that have been going on out there. So that's D. Okay.